In this video, we're going to talk about mathematical modelling in mechanics. Now, if you want to model the path of a ball, for example, we have to simplify the situation, and that means making some assumptions. So, in this situation, a bowler throws a cricket ball. What assumptions would you make? Well, here are some. Now, first of all, we'd probably assume there's no air resistance. And then we might assume that there's no spin on the ball, that when the bowler throws it, he's not going to make the ball spin round. Another one might be, let's assume that the acceleration due to gravity is always a constant value. Another one we often do is that let's assume that the ball is very small, that it's a particle. And let's assume that the ball is moving in a plane, so we can use the x-axis and the y-axis to model our ball, or our path of the ball. And very similar to no air resistance in a way, let's assume there's no wind. And we'd always try and simplify our model as much as possible, so it makes the mathematics easier, and then we'd make it more complicated if we needed to. But if a simple model works, then a simple model is usually better. Going back to one of those assumptions about modelling an object as a particle. Now let's say we've got a particle, and I'll make that particle even smaller. And we've got some forces acting on that particle. So let's say we've got a force pushing it down, and then we've got another force, an equal force, let's say, pushing it up. I'll just move those. And they're equal forces, let's say, so now it's not moving. And then let's say we've got another force pushing it to the left, and then another equal force pushing it to the right. And now we can see, because it's a particle, all of those four forces are acting at that single point. And that's very useful when we're creating a mathematical model and trying to form equations. So, one of the main thing related to modelling an object as a particle is the fact that all the forces are acting at a point. Now, if we have a larger object that we can't realistically model as a particle, what happens? Well, we've got our four forces that were all acting at a single point when it was a particle. But those four forces, when they're acting on a large object, they may not be acting at the same point. So the upward force might be acting here, the downward force might be acting here, possibly. And if that's the case, what's going to happen to this sort of egg-shaped object? Well, because that one's pushing it down here, this one's pushing it up here, it's probably going to spin round. And then if we get our sideways forces, let's say we've got one here and one here, again that's probably going to make it spin round. So we've then got to take into account extra things that are happening to that object, and it makes the mathematics a lot more difficult. Now you'll be pleased to know that in the mechanics courses that we do, we're always going to model our object as a particle. Now, how would the above assumptions change if the ball was very big? And if the bowler put a spin on the ball? Now looking at those, we're probably going to have to change this second one here, no spin on the ball, because obviously we've decided we're going to have spin on the ball, so we've got to eliminate that assumption. We've said it's not a particle, so we're going to have to eliminate that assumption. But We've also got this one here, that the ball is moving in a plane. Now if the ball is spinning, it may be moving up and down, but it may be also moving backwards and forwards. So we're probably going to have to eliminate this one here, that it's moving in a plane, because it probably isn't moving in a plane. So the fewer assumptions that we've got, the more complicated the model will be. Now, just before we have a look at those, let's have a look at a simulation here. So this is our simulation for throwing a ball, or throwing a ball up in the air. So we can, because we're working in a single plane, we can use our axes, our horizontal axis and our vertical axis, and then we're going to fire the ball. Now we're going to assume as well that it's going to be thrown from this point 0, 0. So we're throwing it from the ground and it's going to land on horizontally in the same position. So if I fire the ball, here we go. And that's our model for a ball using no air resistance, no spin, modelling as a particle. And we can probably see, actually it forms a parabola. Just going back to our slides here. One away. Moving on, we've got other assumptions. Now, assumptions that we often make in our mechanics course is about a string. Now, we're often modelling a particle on the end of a piece of string. And we generally assume that it's a light string, and this means that we don't have to take into account the mass of the string. And another one is it's an inextensible string. Now what that means is that the length of the string doesn't change, so it doesn't stretch out or squash in. And the reason why we make that assumption is so that we know that the tension all the way along the string will always be the same. Other assumptions that we often make is it's a smooth surface. So objects moving along a smooth, generally horizontal surface are not affected by friction. So we can ignore friction if we say it's a smooth surface. And the last one, which we've already mentioned, is a particle.